Hey, what's up? In this video, we're gonna study this function right here, this to see if it's monotonic increasing, decreasing, or constant on an interval. The function is f of x equal to x to the power 4 minus 2x to the power of 2. To do that, we will first start by finding the zero of the function. And under this condition here, f prime of x should be equal, and then we will solve the equation f prime of x equal to 0. So taking the first derivative of the function, f of x will be equal to f prime of x, of course, is equal to 4x to the power 3 minus 4x. That's the first derivative function. And we have to solve this equation to equal to 0. So we having now 4x to the power 3 minus 4x equals to 0. And here we will factor 4x. Of course, we have a 4x, pardon, 4x. We'll factor 4x, and remain here x to the power 2 minus 1 equals to 0. And this is a perfect square. We know that it means that we're having here 4x times x minus 1 times x plus 1 equals to 0. And when you got three terms equal to 0, if you got a times b times c equals to 0, it means that what you're having here is either a equals to 0 or b equals to 0 or c equals to 0. That's what it means. So we're gonna have here 4x equals to 0 or x minus 1 equals to 0 or x plus 1 equals to 0. Okay, so if one of the three is equal to 0, the whole thing is going to be equal to 0. So we're having here for the first one x equal to 0, and here x equals to 1, and the last one is giving us x equals to minus 1. So our zero of the function are, we're having three value: x1 equals to 0, x2 equals to 1 or minus 1. I mean, 1 I put it this order, it doesn't matter, and x3 equals to minus 1. So we're having three values for the zero of this function right here. Now we're going to draw a monotonic table to represent, the interval of, the value of our 0 of the function, and the interval where the function is increasing or decreasing, okay, with their different signs. Before doing that, we can write f prime of x equals x times x minus 1 times x minus plus 1. Okay, just come back here. 4x equals to 0, just divide the 0 by 4, so it doesn't mean 0 doesn't mean a thing here. That's why I didn't even mention it. So we're having f prime of x like this. Now that we have our f of x, we're going to represent all the value of f of x on our monotonic table or table of values, something like that, to represent the sign. So we're having x is having its value right here. It is at 0. X is at 0. Oh, for a different color. X is at 0 here. X plus 1 is at minus 1 here. When you solve x plus 1 equals to 0, it gives you x minus 1. And x minus 1 equals to this value here. It gives us 1 here. Alright, so all values before 0 are going to be negative. Because any value you take here before 0, minus 1 and everything is going to give you a negative value. So, and all the value after 0 are going to be positive. Right, 0.5 gives you positive. And the same thing going on here. With minus 1, we have a minus here, and everything coming after minus 1 is positive. and here negative, 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 and positive. So, and f of x, f prime of x is the multiplication, is the term multiply all together. So we're gonna have minus times minus times minus, it is plus times minus, it is minus, and minus times plus minus times minus plus, and here minus plus times plus plus times minus minus, and plus times plus times plus equals plus. So as you can see here, we can notice that our function is increasing. You see interval here, decreasing in that other one. Oh, pardon, sorry. Other, I mean, it's the contrary. The function is decreasing in this interval here, increasing here in that one, decreasing again in the interval of 0 to 1, and increasing in the interval to 1 to the infinity, to plus infinity, something like that. Okay. Now the second thing to do is to find the maximum and the minimum. We already know that minus 1, 0, and 1, the 0 of the function, are our extrema, but we don't know which one is the maximum and which the minimum. So what we're going to do is to take the second derivative of the function. Okay, and this is going to give us the second derivative of the function f prime, f2 prime of x equals here to, this is the first derivative, is going to be 12x minus 4. This is the second derivative, and what we're going to do now is input the value of the 0 of the function. We had 0, f of 0 first of all will be equal to 12 times 0 minus 4, and this is equal minus 4 and less than 0. So we're having L, it is less than 0 because we're having a maximum at this point right here. Okay, and we're having f prime of the second one is 1 equals to 12 times 1 to the power 2, excuse me. Okay, it is 12x to the power 2. So 0 to the power 2, it doesn't mean anything there, so it's alright, it's everything okay. So 2 minus 4, it gives us here 12 minus 4 will be 8. This is bigger than 0. This is a minimum, and f prime of minus 1 is going to give us here 12 times minus 1 to the power 2 minus 4. That would have made a difference here, equals to 12 minus 4. It's also equal to 8. So this is what our conclusion. We're having a maximum here, a minimum here, a relative maximum, a relative minimum, a relative minimum here, and then also relative minimum at this point here. I mean, the relative maximum is 0 and 0. Of course, the relative minimum would be at this point here 0, and what is it here? 0 and 0, minus 1 and 1, and minus 1, or 1 and minus 1. Okay, now that we have everything here, we can say that I mean, we knew that from the very, I mean, when we had the 0 of the function, we knew this value were the extreme of our function. So now we have the maximum and the minimum. So what we can do now is draw our function to see if everything we've been doing here is really I mean, just match what the function tells us. Now this is how the graph of our function looks like. We said that we were having our 0 function where 0, 1, what was that? Minus 1, 0, and 1. We have here minus 1, 0, and 1. And we said that the function in the interval of minus infinity to minus 1, the function was decreasing. This is what we got here. The function is decreasing until minus 1. In the interval of minus 1 to 0, the function is increasing until here, and from 0 to 1 is decreasing again, and from 1 to 0 to plus infinity it is increasing. And we also say that, talking about the maximum and the minimum, that we had a relative maximum at 0. This is what we got here. This is a relative maximum. We have a relative minimum at 1 here, and a relative minimum at -1. This is here our two minimum, or I can put it like this. This is a minimum, this is a minimum, and that's here is a maximum, and that's what we can get here. That's our relative maximum here. We stop here, and our relative minimum are this one right here and that one there as a function. And the zero of the function are here, 1, 2, and 3. -1, 0, and 1. That's what we got here. And the interval, the function is decreasing, increasing, and just like we said here by studying the function. So we can just say here to finish that with our function, the function is not constant, but the function is increasing and decreasing. That's what we say here: monotonic increasing and monotonic decreasing. We have the monotonic decreasing twice and monotonic increasing 2 times. The function is not constant. We have in the different interval. We can even write the interval like this. Say that in an interval of -infinity to -1, the function is monotonic increasing. Monotonic increasing. And in the interval of -1 included to 0, decreasing here first of all, okay, decreasing, and now the function is monotonic increasing. And in the interval of 0 to 1, the function is monotonic decreasing again. And on an interval of 1 to +infinity, our function is monotonic increasing. And that's for sure what we got in a graph in this clip right here. Okay, so thank you for watching again. Until next time, bye bye.